Okay, Lu Ling told us a little about, you mentioned the numbers in the abacus, so I'm going to, because you can't escape, because it's very tight here, I'm going to tell you a little about Chinese mathematics, and you can't go anywhere, so you're stuck. No, it won't be bad. It's really a show and tell. So mathematics in China started like in the other cultures, Greece and the Arab world and India and Egypt, with looking for ways to boost their agricultural production, to do trade, weights and measures, all that stuff. They weren't looking for pure mathematics or any of that science. So about 2 BC, they came up with the abacus. We see these in paintings, but they weren't really used that much until later. But all cultures came up with some kind of counting stones or rods or something like that. So before the concept of a number came out, a merchant would know that if I've got 3 pot stickers here and 4 pot stickers here, and I move the piles together, I can count and there's 7 pot stickers. It took centuries for people to learn that that number 7, whether it's pot stickers or apples or potatoes or whatever, that was a concept in itself. And it's a brilliant transition from just counting whatever it is for apples or pot stickers or whatever. So they had these stones, and then they had these counting rods to make it easier. They have these stones on a rod, and they slide it over, and 2, 3, 4, and then they just count them. So in all the cultures did that. In China, what happened though, they were isolated geographically and by language more so than the Greeks, the Egyptians, the Arabs, because they had the Mediterranean, they were all pretty close there. So there was some cross-pollination of ideas. Until the Silk Road, really, there wasn't a lot of cross-pollination between China and the more Western cultures. So they developed their mathematics and other science independently. Some of it ahead of time, like they had the Pythagorean theorem that was a little behind the Greek one, but they had some concepts that were ahead of the Arabs or Indians or something. Once the Silk Road traveled, China kind of balanced out with the other cultures. But what happened in China, after right before the Ming Dynasty, there was a dynasty of Mongols. And when they were defeated, the Ming Dynasty, the leaders of that dynasty, didn't trust the knowledge that was gained during the previous regime. So they basically threw it out and said, we're going to figure out our own stuff. So they threw out most of their math and physics and focused on botany and pharmacology and things like that. So all the herbs and the healing and all that. So the mathematics really suffered for a while. But what they did do, which was brilliant, we got an abacus. And abacus is not just Chinese. They're Eastern Europe, Middle East, Africa, Korea, Japan. But China's an abacus in China, what's it? I'm going to pronounce this wrong, but it's Swanpan. Lu Ling is Swanpan. Swanpan. I'm going to call it Chinese abacus. Okay. So if you see a Japanese abacus or something, you'll see 4 beads below. They call them the earthly beads. And on top they'll have 1 heavenly bead. Okay? This is Chinese. It's got 5 earthly beads and 2 heavenly beads. So you can do things with that that you can't do with the Japanese and other abacuses. And what happens is, we think of it just as counting. And basically the concept of the abacus is you can have whatever width you need. This is 11. So here's the units, the tens, the hundreds, thousands, 10,000, 100,000, million, 10 million, 100 million, billion, 10 billion. So you can have this, or you can have to the other side of the decimal point. So you can go way back. And some of the Chinese scholars found like the square root of 2 to 25 places and all. So it's a pretty powerful thing. It's not just adding. But say I just wanted to add, whatever is at the middle beam is what you count. You ignore everything else. So if I'm putting, like here's, it's going to slide, but here's 123 and I could add other things. So you do your stuff, you do your calculations on this. But what's interesting about the Chinese abacus, that's Swanpan, or whatever that is, because it's got 5 of the earthly beads and 2 of the heavenly beads, you can get 15 characters there, which means you can do hexadecimal stuff, which before your eyes glaze over, we as humans all use decimal because we have 10 fingers, 10 toes. So all the cultures came up with decimals, a base 10 system, 1, 2, 3, so we could count like that. We all know binary, that's what computers use, 0, 1. That's a binary system, so off, on, high voltage, low voltage, dark, light, whatever, that's binary. But hexadecimal uses 16 characters. So it's 0 to 9, and then A through F. And why that's important, back in the day, the Chinese merchants and traders used 16, the number 16 for their trade. So there might be, like we have 16 ounces in a pound. It was natural for them to trade things and do business with 16. What makes it good for us now, in the computer world, hexadecimal is very important. Okay, so we know that computers do zeros and ones. It's binary. So if you have 1 byte, and I don't want to get too technical, but a byte, say you're typing a letter, every letter is 1 byte. So the letter A, say I type it on my keyboard, that takes up 1 byte of space. That byte can be from 0000000 to 11111111. So it can be in the range of that. It could be 01101, 8 characters there. In hex, we can just go from 00 to FF. So it's so much more efficient. It's easier for humans to work with and deal with. And you can do hex on these because when I get to 5, then I can go to 10, 15, and as soon as I get to 15, I need 16, I just push one of these up. So you will see people are still using abacuses around the world. Eastern Europe, Middle East, Africa, Far East. They teach people this, and you'll see people, their fingers flying. And they're doing all these fantastic calculations with their fingers flying. And you know that whenever you do something like that, whether it's typing or knitting or you see kids texting or something, it becomes rote. So you will see people, students who have mastered the abacus, and here they are, they're doing their thing, they're moving it loud enough, and then you take the abacus away, and they can still do it. So they're going like this and all, and they're still able to do abacus calculations without the abacus. It's kind of like in the 70s, from Korea, they had something called Chisenbop that came over, and you could do that with just your fingers. That makes it good for blind and visually impaired people. Now there's talking calculators now and computers and stuff, but in a lot of blind schools for the blind and visually impaired, they'll teach the abacus because you learn all the functionality and reasoning behind mathematics without just saying, what is 4 times 6? You learn to do it, and blind kids can do this because they're feeling it.